Sean Lane is the CEO and co-founder of Olive. He started his career in intelligence at the Department of Defense and the NSA. He served 5 combat tours in Iraq and Afghanistan and was awarded the Defense Meritorious Service Medal and Bronze Star Medal for his service. After his government service, he founded several technology companies dealing with big data, advanced analytics, entity resolution, and most recently, AI, and is now a leading expert in applying AI to healthcare. Welcome, Sean Lane.
Thank you. So thanks for hanging in there. I'm the one who stands between you and lunch. I appreciate it. It's been a great morning, learned a ton. I'm going to zoom through. There's a couple points I want to make, but we'll try to make this as quick as possible. So today I'm going to talk about scaling humans. So the idea of scaling humans is to really get more out of the human workforce we have today in healthcare, and doing that using artificial intelligence. Before we get into that, a little background on myself. As was mentioned, I was in NSA for most of my career in the intelligence community. There I really dealt with enormous amounts of data, hundreds of thousands of rows of data coming in every single second, all from heterogeneous sources, non-cooperative sources that we had to then bring in database and then make sense of so that we could create software applications to give to warfighters to catch bad guys. Incredible experience, but it really allowed me to learn a ton about technology. And even though that was my cool war picture, I really looked like that. So that's what I looked like in Iraq and Afghanistan, not really with the gun in Fallujah like the picture shows, even though I did have a few of those cool pics to send home. I got out of the intelligence community and jumped right into healthcare. And I did that because after getting out of NSA, founding a company in military intelligence, selling that company, my hometown in southeastern Ohio came to me and said, hey, we're having a huge problem with prescription drug abuse. Can you help us solve this problem? So I started looking into healthcare about 2012. That's when I saw something that I had seen before. It was data silos, information not being connected, systems not working with each other. It's the same thing I saw in the intelligence community prior to 9/11. So I determined at that point, healthcare doesn't really have the internet, and that's what we need to build. But I also realized that building the internet of healthcare wasn't as easy as just homogenizing data sources. It wasn't easy as creating APIs and different interfaces between different systems. It had to be much greater than that. Because the other problem I saw in healthcare was there were all of these screens. You were always logging into a portal, an EHR, one screen, another screen. And the best thing that anyone in Silicon Valley could come up with was another screen. A sexy user interface, they would call it. That the current EHR is no good, but the sexy user interface will be better. But it was only doing 2% of everything that the EHR was doing. So we made a statement early on in Olive that we were not going to create another screen. We were going to instead use the software that already existed. We were going to teach an AI robot to use the software that already exists in healthcare, just like a human would use it, and take over many of the tasks that humans currently do. We did that because of a lot of advances that have been made in computer vision. Computer vision is the foundation of Olive. It is the foundation of what we're able to do. Olive can look at any software program, any application, for the first time she's ever seen it. She can understand how to use it. She understands how to navigate an EMR, how to do simple tasks, how to use a portal, how to log in, how to search things, how to create reports, how to query databases. The very first time she's ever seen a piece of software. And that's using computer vision. We have built many convolutional neural nets based on software interfaces to teach all of how to use the software. But I want to talk a little bit about the scaling concept for a second. What is scaling? It's getting more out of less. Humans over the years have scaled through tools. As a humankind, that's what we use. Tools like fire, the wheel, printing press. We had information in our head. We needed to get it out to many people. We needed to carry things, heavy things, for longer distances. And then the final kind of tool for scaling was this personal computer. You know, there were two technologies in the early 80s, really. There was the mainframe and the personal computer. The mainframe was fantastic. It had a lot of sophisticated, complex capabilities. But nobody really had access to it. Certain businesses had it, but the normal everyday person didn't have it. It wasn't until the PC, until everyone had democratized access to this technology that really changed everything. With artificial intelligence, we're kind of in early 1980s. A lot of people know about AI. Not very many people have access to it. But as the access to AI gets democratized, we're going to see this huge scaling using this tool. Steve Jobs is pretty famous for telling this story. It's about a study that was done, and it was looking at all the creatures in the animal kingdom. And it was studying which one could go the farthest distance with the least amount of energy expended. The condor won by far. The human was pretty far down on the list, didn't do very well. However, when you gave the human a bicycle, the human beat all the animals in the animal kingdom. It could go farther than any of them with the least amount of energy expended. And Steve Jobs liked to say that the computer was the bicycle of the human mind. It was that tool that we used as a human to go farther with the least amount of energy expended. We believe that AI is the bicycle of humankind. It is the tool that we will use to do all those crazy moonshot things that we talk about today, like occupying Mars, or creating a new sustainable energy source, or curing cancer, or fighting to extend life expectancy. It's AI that will give us as a humankind those kind of capabilities. So we at Olive believe in the Turing definition of AI. We believe in the Turing test, being unable to distinguish human from technology. And we try to run our technology through the Turing test. We believe that was the foundation that began it all, so we kind of go back to that. And using that philosophy, if humans used tools to scale, then AI should use tools to scale too. Fortunately, over the past 30 plus years, we have been building tons of tools. We've been building software applications, apps, whether on a desktop, a PC, a Mac, an iPhone, an Android. We've been building all these apps. What if we could create a software robot based in AI that could use this software just like a human could? Imagine how we could scale AI at that point. So we use a few concepts in Olive to make Olive. One is robotic process automation, otherwise known as RPA. It's a pretty fundamental, pretty basic capability. Allows you to evoke and action anything on a software interface, how to click, type, interact with a piece of software, just like a human would. We also have this concept called global awareness, which is really important. When Olive is working, let's say on a patient, on something with a patient across multiple systems, maybe it's 2 different EHRs at the same hospital, maybe it's an EHR in 15 different hospitals. She needs to understand who that patient is across all those systems. So that's an entity extraction, entity resolution capability that we call global awareness. Global awareness is incredibly important in creating this type of artificial intelligence. And the third is machine intelligence. This is really using historical data to create either machine learning models or deep learning models that allow Olive to make a decision like a human has in the past. So imagine a human looks at claim denials. Claim gets denied. Humans for years have been remedying these denials. So we know now, looking at the historical data, how a human responds to a certain claim and how that human can reverse that claim successfully. So we just train Olive with the same feed-forward neural net that a human would use to make these decisions and put that as part of the workflow process. That's an example of machine intelligence. So it's really those 3 things together: the RPA, the hands, the global awareness, the understanding of who people are, and what entities are across many systems, and then the brain, this ability to make decisions like a human that equals AI for us. So we created a super connected intelligent learning bot, or what we call a skill bot. Super connected as in every Olive can talk to every other Olive. So an Olive logged into an EHR, Olive logged into a portal, an Olive logged in at one hospital or a healthcare company, they can all speak to each other. They can speak to each other, they can exchange information, they can pick off where one left off, they can take a process all the way from one end to the other. And they learn every time how to get better results, how to be more successful, how to complete the task. So Olive uses all the crappy software that you already have. She doesn't need to come in with anything new. She loves EMRs. She loves all that crappy software that healthcare already has, and she uses them very, very well. Aesthetics aren't so important to Olive. It can actually be faster for her to learn how to use something that the aesthetics aren't completely great on. So imagine, for example, Olive is logged into one EHR in your hospital. Let's say it's an acute, to those who work in healthcare, on the acute side, and then one on the ambulatory side. And they're conducting some kind of process. And the two Olives can then share information with each other. Now imagine that across 3 different systems. Now imagine it across many systems. What you end up with is this federated query capability, where you can ask Olives that are logged into many, many systems a question like, have you ever seen anyone with CHF? Olive could then take CHF, explode it into many query terms, and query many, many systems with it, return and compile all the results. So let me tell you a story about this guy. He was on his way to Aspen. He had to return a briefcase to Mary Swanson, and he had a chip in his tooth he was trying to fix. But he was in Idaho, and he'd never been to Idaho before. He had to go to the dentist very quickly, so he texts Olive and says, Olive, I need to go to Idaho, or to the dentist, I'm in Idaho. Olive says, great, I'll find a place for you. Olive is logged into all their practice management systems, so she sees which appointments are available. She goes ahead and schedules his appointment. She asks all the other Olives to compile his data, brings his data together, and puts it in the system for the new dentist. And then he got his tooth fixed, and Mary Swanson said he had a chance. It was 1 in a million, but it's still a good chance. So let me tell you another thing about this company here, Google. We've all heard of Google, I think. But this is one of their very first interfaces. They have done an incredible job at organizing the world's information. But what they haven't done is organize the world's enterprise information. They haven't organized the world's health information. Imagine a query capability that would allow you to query an army of bots. These bots all logged into different enterprise systems, able to apply an ontology, a dictionary, a lexicon to your query, expand it out, get as much information as possible, and bring it back. That's kind of the AI future that we're working on. Talked about that. Our vision is that thousands of humans can build millions of skill bots. And how do we do that? We do that by creating a platform so that anyone can build an Olive. That you could take an easy platform, build an Olive, and that Olive becomes part of the internet. Your Olive, who's going out there doing some kind of task, doing some kind of learning, making decisions like a human, joins a network of many, many Olives. And over time, we have millions of Olives in healthcare able to retrieve data, be able to answer questions like a human. So just some food for thought. Imagine in the future what it will be like to purchase software when you have to ask the question, how will this work for my AI workforce? I have 1,200 AI employees right now that I hired, all doing different tasks. And this new software I want to buy, I want to make sure that the AI workforce can use it well. Imagine the questions we're going to have to ask software vendors in the future. Imagine questions of what that UI should look like for those bots. All right, I went fast on that because I wanted to get everyone to lunch, but I would love to open it up for some questions. I've got about 15 minutes, but hope maybe we can do it in like 5 or 10. Any questions?
Yeah.
Oh, go ahead.
How do you deal with like privacy or any data that might be regulated under that?
Yeah, so how do we deal with privacy or regulated data? It's a really hard challenge, and that's been part of the issue and why we created this version of the internet. If we just opened the floodgates for all the data to transfer, then we wouldn't be able to incorporate the business logic and business rules we needed into a point-to-point kind of communications. Like if I have 2 organizations that want to share data very, very specifically for very specific business reasons, I can build that into each bot. So it's not a fire hose of just free flow of information. It is an arduous, complex system of business rules between each individual bot. In many cases, there'll be layers of complexity that we can't even keep track of. But I think that's what's going to be required in order to share in this really highly sensitive area. We were doing similar things in the intelligence community, at the row level of data based on who had access and privileges to that information. It's very, very difficult, but it is doable. It's not intractable.
Great talk.
Thanks.
I've spent a lot of time looking at how to federate these kinds of solutions and how to manage ontologies. You did use the word ontology. And the problem is that people use different ontologies for the same data with different design points for different purposes and use cases, and that different data sets are using different versions of the same ontology, let alone different ontologies. So have you developed a strategy for how to use machine learning to disambiguate some of the metadata around the ontologies in use in the different localizations, so that when you do combine queries across multiple nodes and multiple olives or skillbots, that you have some way of compensating for that without the usual semantic degradation of ontologic impedance mismatch?
That's a great question. So I think the way that we're thinking about it initially is bringing back more data than we absolutely need. So being larger than discrete in the results that we bring back. And a lot of that, we're actually using graph theory. So in the response of all that data, we're using some basic, basically ranking algorithms, similar to what Google uses, but mostly like eigenvector and cat centralities to rank that data. And then what we hope is we have two layers that are additional onto that third layer. First layer is actual user interaction with the data as it's queried and use of that data as another layer for ranking of the information. And then the second is published data as a result of analyzing the federated result of the query. So you take those results of the federated query, you add some layer of analytics on top of it. That becomes another piece of information that gets returned in search results. So it's another layer. So essentially, if I query CHF, I'm going to have something that turns it into ICD 910, all the codes that kind of materialize from that, LOINC, SNOMED CT, everything that materializes out of that. And I'm going to have this huge dragnet of a query term. And then I'm going to hit everything I can and pull back a bunch of data and then rank it. And that's how we're going to start. Because it is a huge problem and a very difficult thing to understand without the user interaction data. Other questions?
Hey.
Oh, sorry.
Thanks, Sean. Great talk. Two questions. One is in terms of how Olive itself is trained. If I understood you correctly, it is following the workflow that a human would between systems.
Yep.
And using machine vision, you're actually seeing what's happening during in the interaction. If that's true, the second question related to that is how do you deal with unstructured information? For example, physician's notes or images, things along those lines, upon which a human being often makes interactive decisions in the data. Just wanted to know how you deal with that part of it. So.
Right. So there's two elements here that you mentioned. One is using what the humans had done historically to train Olive on what to do kind of in a serial way. And then the second is the machine vision or computer vision to learn how to interface with the software. So we kind of abstract that out where we use computational ethnography, essentially, to look at what the human has done, every click, every keystroke, everything. And we reconstruct their workflows. We call them circuits, and we use graph theory for that as well. I'm kind of a graph nerd. So after using the graph theory, we can determine the circuits by basically looking for isomorphs inside the graph. And then we take that and we apply it to the computer vision layer that we understand, but it's not like a one-to-one kind of match. It is, this is happening, and we go back kind of semantically to Olive and say, search for this patient. And she knows how to do that on the screen. So it's kind of, they're separated and abstracted. But when it comes to unstructured data, we're not necessarily extracting out, like doctor's notes, for example. We're just knowing that the human's interfacing with them. And we do entity resolution inside all of the unstructured data and index it to provide some structure to that unstructured data. And that's essentially, so very basic kind of entity extraction and indexing. Welcome. Any other questions? Well, thanks so much and enjoy lunch. It's a pleasure to be here.